Okay, so welcome everyone to the last tutorial session on the course of Foundations of Cryptography. Let me just share my screen, and what I will do today is that I will discuss the 5 questions from the NPTEL website for last week, and then we can just discuss if anyone has any doubt. Okay, so let us start. So first question of last week's assignment was this: multiplicative inverse of 129 modulo 1677 is what? Anyone would like to answer this?
Doesn't exist.
Does not exist. Why? Can you tell why? Hello. So basically, as you can see, 129 divides 1677, right? So this number is divisible by 129, and that means GCD of these two numbers is 129. So as you know, for a group ZQ, right, any number between 0 to n minus 1, which are the members of the group ZQ, the numbers which are co-prime to Q, those are the numbers for which multiplicative inverse modulo Q will exist, right? So I should, if I write this, in the set ZQ that contains all the numbers from 0 to Q minus 1, only the numbers that has GCD 1 with Q, right, those only have multiplicative inverse modulo Q, right? And since here in this case 129 completely divides 1677, that means GCD of these two numbers are 129, and since it is not 1, they are not co-prime to each other, so multiplicative inverse does not exist. Which of the following is or are false about zero knowledge proofs? The verifier can always learn something about the secret information that
if
yes.
they were co-prime to each other, then what will be the multiplicative inverse?
So then you have to follow some particular inversion algorithm that you can actually search how to compute multiplicative inverse modulo some prime, right? Prime, or if it is a composite number, then maybe you have to do something by dividing it into its prime factorization and trying to find that. You can look into that actually. You will find some algorithm. Okay, so coming to the next question, which of the following are true false about zero knowledge proofs? The verifier can always learn something about the secret information that the prover possesses at the end of the proof. So is this true or false? So the purpose of zero knowledge proof is that if there is a prover who is trying to prove that it has access to some particular information, say X, then a communication happens between prover and verifier, and at the end of that protocol, verifier should be convinced that P indeed has access to that secret information X, but B should not learn anything about X, the secret information itself. So that is the purpose of zero knowledge protocol. So this statement is wrong because verifier should not learn anything about the secret information. It should have zero knowledge about that secret information. So this is wrong. and it is asking which are false, so it will be false. Completeness and soundness are not the only properties that must be satisfied by a zero knowledge proof system. So there are three properties which are satisfied by a zero knowledge proof system. One is completeness. Completeness says that if the prover indeed has access to information X, then the proof should always convince the verifier that P indeed has access. So verifier should always be convinced if P indeed has the proof. And soundness says that if P does not have access to that secret information, if prover is actually a cheater, then verifier should never be convinced. That is the property of soundness. And there is another additional property which is called zero knowledge, which says that at the end of the protocol, verifier should not learn anything about the secret information. So this statement is correct. Third statement says all zero knowledge proof systems uses asymmetric key primitives. So this is basically wrong, but for example purpose, right, you can actually search what are the zero knowledge proof system that you can achieve using symmetric key primitive, but it is possible to build, right? So this statement is wrong basically. So this is a question about Samir secret sharing. So the four options are given, like in the NT replicated secret sharing scheme where T is less than n-1, there are a total of n choose T instances of additive secret sharing scheme. So is this statement correct?
This is false.
This is false. Okay, why?
Because the total number of instances should be n choose T plus 1.
Okay, acha, actually there are two different terminologies here. When you say some n out, T out of n system, right? I think in the lecture when they say NT replicated sharing, I think they, like, how do you reconstruct the secret? For that, whether T shares are necessary or T plus 1 shares are necessary, there are two different terminologies actually. Both are correct, like the way it depends on the way you define your secret sharing scheme. If you mean to say that T numbers of shares will be required to reconstruct the key, right? In that case, NCT number of additive secret sharing instance will run actually. So for example, let's say I am saying that 3 out of 5 system, which will mean that there will be requirement of 3 shares coming together to reconstruct the key. In that case, what you do is that all the possible subset of size 3, right? Let's say P1, P2, P3, P1, P2, P4, P1, P2, P5, and P2, P3, P4, P2, P3, P5, and P2, say P2, P4, P5, right? And okay, let me see here also. So there will be total 10 possible subsets, right? Which one did I miss? 1, 2, 3, 4, 5, 6, 7, 8.
P3, P4, P5.
That's the last, and another one is missing. P1, P2, P3, P2, P4, P4. Okay, there is P1, P2, P4 also. Anyway, so there will be total 10 possible groups of 3 entities, right? and then for each of these entities you perform one additive secret sharing scheme. So if you consider n out of t means t shares will be required, then this is your answer. And if you mean that 3 out of 5 means 4 shares will be required, or in other words 3 shares together cannot reconstruct the key, in that case your answer will be different, right? Then if t plus 1 shares are needed, then maybe you will do nc t plus 1 group and then secret share, right? Okay. And second statement says that given t distinct points in the two-dimensional plane, there are an infinite number of t degree curves that can pass through the given points. So you have a t degree polynomial, that means it is of the form some say at xt at plus t minus 1 x t minus 1 and so on till a0. So a total of t plus 1 different coefficients are present here, since it is a t degree polynomial. So you would require at least t plus 1 number of xy pairs, where x is some given point and y is the evaluation of this function on that point x, right? So if t plus 1 number of this xi pair is available to you, that is the function evaluation at t plus 1 different points, then only you can uniquely identify the polynomial, right? So okay, so that's why with t number of points available, actually you will have infinite number of curves possible. Just a minute, sorry.
Hello. Hello.
Okay. Now third statement says that in NT semi-secret sharing scheme with polynomial coefficient chosen from a finite field, the probability distribution of any set of t shares is dependent on the underlying secret. So what is the so is this statement true or false?
This is false.
Why?
Because the T shares can have multiple secrets, infinite secrets.
Right. So basically, otherwise the scheme will not be secure. Only the Samir secrets sharing scheme is secure because the probability distribution of any set of you can create multiple sets of shares for the same secret, right? And that's why the security of the secret sharing scheme is there, right? So this statement is false, right? Okay. Consider the following variant of additive secret sharing for sharing a n-bit secret among n shareholders, right? Such that so you have a n-bit string and each bit of the string you actually give to one party. So S1 to Sn, that is the bits of the secret, and the ith position bit, say Si, is given to party Pi. Now you have to comment on the security of this modified additive secret sharing scheme. I think we discussed this question last week, so you can just answer it.
The scheme is not secure.
Not secure, right? Because n minus shareholders, if they are corrupted, so that means you already know exact bit value of n minus 1 positions of S, and for the rest bit you actually can have only two possibilities, 0 or 1. So that is with probability half you can guess the correct bit, so it is not secure. Choose the correct options from the following. A secure secret sharing scheme cannot be deterministic. A Is this true or false?
Ma'am, didn't understand this sentence.
Okay, deterministic means that any procedure, when do you call it deterministic? That so secret sharing scheme, that's an algorithm, right? You have a proper way defined how to do secret sharing, right? Now in this algorithm, if there is some step which involves randomness, then we call the algorithm randomized algorithm or probabilistic algorithm. But for the same input, if an algorithm always outputs the same value, then it is a deterministic process or deterministic algorithm. Now for secret sharing scheme, any defined secret sharing scheme, given a secret, is it the case that always you get the same secret shares every time you run the secret sharing algorithm? Do you get the same shares for the same secret?
Yes, we did.
No.
No, no.
No.
If T plus one parties they get together, they will get the same secret.
No, that's the reconstruction phase. But when you share, let's say when you are doing additive secret sharing scheme, right? So let's say I am in Z10 group, okay, and I have to share the secret 5, additive secret sharing. So what you do, your algorithm does this following, right? So you have to share this secret among 3 parties, okay. So what your additive secret sharing does is that first it chooses 2 secrets uniformly randomly from Z10, right? Let's say S1 is allocated. So first time you are running the algorithm, you are getting S1 as 4 randomly generated, so there is randomness involved. Then you are sampling again another random value from Z10. Let's say this value selected is 6. Now the third secret, actually what you do, you basically do this, right? S minus S1 plus S2 mod 10, and then you get so basically 5 minus 10 gives you minus 5 mod 10, that is 5 mod 10 again, such that when you combine all 3 of them, you do S1 plus S2 plus S3, then you actually reconstruct the whole secret, right? So mod 10. Now these 2 steps, computing S1 and computing S2, will vary depending on each time you run the algorithm again. So next time you run the algorithm, it may happen that S1 gets assigned the value 3, S2 gets assigned the value 4, and then you compute S3 to be 3, right? So 4, 6, 5 is a secret shares generated when you run the algorithm first time with the same secret S equal to 5. When you run the algorithm again second time with the same secret S equal to 5, you get the shares generated as this. So this is a randomized algorithm, and this is required for the security of secret sharing scheme. Otherwise, if it is the case that for the same secret you always get the same set of shares, then everyone, the adversary, will also know what is the output of secret sharing. So they always already know what are the shares that the parties have. It is because this randomness the secret sharing scheme is secure, because adversary does not know which set of shares have been generated from the secret sharing algorithm, right? Okay. Samir secret sharing uses public key operations. So there is no as such public key operation involved in Samir secret sharing scheme. So by public key we mean that is there any kind of public key primitives involved? It's not the case, right? You have a secret and you just share it. There is nothing like some Diffie-Hellman or some kind of key exchange where some public key, secret key things are involved, nothing like that. So the statement that Samir's secret sharing uses public key operation, that is wrong. Samir's secret sharing uses polynomial interpolation to reconstruct the secret. It is true. So polynomial interpolation means that given a polynomial and if you are provided with t plus 1 distinct points on a t degree polynomial, then you are able to uniquely reconstruct the secret, right? And the fourth statement says that the message space for Samir secret sharing is compulsorily a group. This is again not true, because as you know that Samir secret sharing scheme needs the message space to be a field, because you have to perform inverse operation on the elements. So all the elements in the set needs to have inverse. So group will not suffice to do that. You need a field for that, because for field, except the additive identity element, every other element has the inverse. So that's it for this week's assignment, right? Now if you have any question, you can ask. Before that, just give me 5 minutes, I will be back. If you have any doubt, you can ask, we can resolve that, okay? Just give me 5 minutes.
স্যারের সাথে কথা হয়েছিল না আজকে, আমি বললাম আজকে আমি কালকে রাতেই কথা হয়েছিল, তো ও বললো ওর জন্যই ফোন করছিল, কারণ দাদা স্যারকে পিং করেছে কিছু রিপ্লাই না। আমার জিরো করে ফেসবুকে লাগাতে জিরোটা সেট হবে আমার
any question? Anyone any doubt about the syllabus? Also someone asked last week about, like in the last tutorial session, whether do we have access to last year questions or something. So let me tell you that the candidates who sits for exams, the exam is online, so they don't have access to the questions actually. Once the exam is over, they can't get the question with them. So it's not possible to get access to any year's questions. But also I asked one of my friend about the standard of this NPTEL exam. So it will not be very difficult. The question level will be same as the assignment questions that you get every week. So the difficulty level will be same as that only. So just go through the assignment questions and the broad topics on each of the tutorials, videos. The actual videos, I would suggest that just go through all the 12 weeks actual videos, and then for support you also have access to all the tutorial sessions. For my sessions and the other TS sessions also you have access to. You have enough materials with you, so prepare yourself well for the exam.
Ma'am,
Yes.
how many maths we are going to expect?
There will be a total of 50 question, okay, and the time is 3 hours I think. So just as I said, I asked one of my friends, so you will have enough time for each of the questions. Just be calm and try to solve any
I
of
said
them.
the maths. Will there be maths? A lot of maths?
No, really, right. In the assignment questions also there are not very much of maths, right? It's not too much computation. You should have the basic idea, like the questions like whether some scheme is PRF or not, whether it satisfied PRG property or not, if the encryption scheme is secure or not, CCA security, CPA security, tag verification, so whether a MAC is secure or not. These type of questions, those are mostly based on thoughts, right? It's not very much you have to calculate something. It's not like that. Foundations of cryptography is very much basic, what do we say, like it's about the concepts, right? Not very much doing calculations and all.
Ma'am,
Yes.
a small request. Can you explain the KIM and DIM?
KMD, okay. Key exchange mechanism. So basically the purpose is to, as you have seen, right, that when we are using symmetric key cryptography, that is lightweight. So but we have the assumption that both of the parties communicating, they have access to common secret share. But how do they agree upon that common secret share? For that, key exchange protocol comes in picture, right? Now with KEM, key encapsulation mechanism, what we basically do is that you take help of some public key primitive to share the symmetric key with other party, right? So very broadly speaking, it is like just a minute. So they kind of first sample some key, right? This, so maybe this is done by one party. So it is chosen from some key space. This is going to be the symmetric key for further communication, but it cannot send the key in clear to other party. So for that, it runs the encapsulation mechanism. So it encapsulate using some public key of the other party, right, and encrypts it. So the output of this encapsulation procedure is both K and this encapsulated value C. However, K is kept with the party itself, it does not share or does not communicate K to other party, rather it sends only C, and the other party will decapsulate C, and it is able to decapsulate because it has the corresponding secret key SK. So PK SK are the public key secret key pair, right? And this, with this basically it will have access to key K, and now both the parties are agreeing upon this key K, right? So using public key cryptography, right, you are agreeing upon a symmetric key, and then for the further communication you can actually use this key K and communicate with each other, right? And for data encapsulation, here you are encapsulating the key. If you are also encapsulating the whole data using the same mechanism, then it is like data encapsulation mechanism. Is this making sense? Okay. Anything else?
Yes, ma'am. There's one more thing. Actually, one of my friend is unable to join today, so he has sent me a question. I mean, I'm really sorry. It's a bit stupid. He's
No
asking
problem.
me that whether there will be direct questions from the assignments or not.
I don't know. There can be, right? Direct means if it is a similar type of question, right? You have already seen like enough sample questions over the 12 weeks, right? And it will be almost aligned to them only. That I am saying again and again, that the difficulty level of the questions will be same as assignment questions, and you will encounter similar type of question. Like I said, like perfect secrecy, all these topics that you have seen. So perfect secrecy concept is there is nothing new you can add. So various type of options that you have seen, like been like a bit of twisted versions, like when you write probability of a message M, like probability of the random variable denoting a plain text message being a some particular message M, after seeing a ciphertext C, that probability should be exactly equal to the a priori probability, right? That is without knowing anything about the ciphertext, whatever information you have about the distribution of the plain text, that is exactly equal to the information you will have even after seeing the plain text. That is the concept of perfect secrecy. Now this concept of perfect secrecy can be written in 2-3 several ways, right? Like indistinguishability based perfect secrecy definition and all, like M0, M1 and you see CB, ciphertext corresponding to any of them, and you have to distinguish. And for perfect secrecy you will distinguish with you will give the correct answer with exact probability half. Now these 2-3 types of representation of perfect secrecy are there. So the questions will be around that, like PRF, pseudo random function. So what is a PRF? That given an input, the function is a deterministic function, deterministic keyed function, so there is a key involved in PRF. You see the output, and that output should be indistinguishable from a truly random output by an adversary. Now you will have several constructions of modified PRF, like the questions you have already seen, given some PRF F, secure PRF F, whether the given modified construction F dash is a secure PRF or not. So different type of samples you have already seen. So there can be overlapping, it's very much possible. PRG, what are the things you have read? PRF, PRG, there are this hash function, right? Cryptographic hash function. There is collision resistant property of hash function, right? Which says
There
that
is some problem
Yes.
Then there is some questions. Which one is the which one hash function is
Hmm.
collision resistant?
Okay.
I am little bit confused in those type of questions.
Okay. Do you have any particular question, or you are asking in general?
I'm asking in general.
Okay, so for hash function, what you basically follow is that whether you are able to find out two pairs of input such that both of them hash to the same output. If you are able to find that, then of course it is not collision resistant. Now let's say if I talk about some example, uh, let's say that it's given some hash function hx is known to be a collision resistant cryptographic hash function. Now you are defining some hash function g such that g of x is equal to h of x concatenated with h of x. Okay, so the question is whether g of x is secure or not. Okay, so can you find a pair of input x1 x2 for g of x such that output of x1 and x2 are the same? So h of x is given to be collision resistant. Is g of x collision resistant or not? What do you think? I am asking you who is asking the question.
No, I think it is not collision resistant
Why?
because there must be same pair in hx too, so there must be collision.
But that does not break the collision resistant property, does it? Right? If so, my argument is that it is not collision resistant because if you are able to find out two such pair for gx for which g of x1 is equal to g of x2, so what will that imply? That imply that h of x1 concatenate with h of x1 is equal to h of x2 concatenate with h of x2. Now this essentially means that first half of this string and first half of this string are same. That means you are able to find out a collision for hash function h as well. So that breaks the collision resistant property of hash function. These two strings same or not, right, that does not break the collision resistant property. So you have to understand what is the assumption upon which your crypto system is built on. So here assumption is that you cannot find easily two such collision pair x1 x2 such that g of x1 is g of x2. So sorry, assumption is that h is a collision resistant hash function. That means for h you cannot find two such pair. Now you argue that g is collision resistant because if it is not a collision resistant function, that implies that you can easily find out two such x1 x2 pair such that g of x1 is g of x2. And if that happens, that also implies, so gx has this form h of x concatenated to h of x. So you can essentially find x1 x2 a collision pair for hash function h also. But that is not true because h is known to be collision resistant. So you conclude that g of x is a collision resistant hash function. Now if the question would have been about PRF or PRG, let's say h is a secure PRG. Let me write G, PRG. So let me write G, pseudo random generator. This is known to be a secure PRG. Okay, with some seed S, of course. Now you are defining another pseudo random generator G dash S, which performs G of S concatenated with G of S. Whether G dash is secure or not. What is your answer then?
No, it is not secure.
It is not secure. Now you can say this because the pseudo-randomness property of PRG says that seeing the output of PRG, you should not be able to distinguish whether this is a pseudo-random output or truly random output. Now you can exploit this property, first half equal to second half, to determine whether it is pseudo-random or truly random, whether it is output of G or G dash or not. Here the pseudo-randomness property is broken, so G dash is not secure. But here the fact that these two half are same, that does not break the collision resistant property, right? You cannot exploit this property to break collision resistant property of H. Okay. Similar question happens with PRF thing. Also, just take a look at like mix and match attack for Macs, right? For Mac you have this, you are given some tag generation algorithm, and you accept the message only if the computation of tag on the communicated message matches with the tag you receive, right? Now there are the way you define the Mac, so there is some how do I put it? So let's say your Mac has this form. Mac has some key, right? Symmetric key. On some message it is performed. So let's say your Mac for message of the form M1 concatenated with M2 is computed as in this manner, right? So is this Mac secure or not? So what is the security property that Mac implies? So you should ensure that there is no chosen message attack possible. What is the chosen message attack? So the adversary is allowed to see tag corresponding to various messages, right? So there is query phase, adversary queries with some message mi and gets to see corresponding tag ti. Now if adversary is able to come up with a new message tag pair such that M star has not been seen before in the query phase, then we say that Mac is not secure because chosen message attack is possible. Now given a Mac construction, you have to determine whether chosen message attack is possible or not. So what is your answer in this case? Can you come up with a new message tag pair by querying for some message? Any answer? Anyone? Is this Mac secure? So F is a secure PRF, okay, that I forgot to mention. F is a secure PRF. So F is a secure PRF implies that by looking at this, you don't know whether this is a PRF evaluation on some message M or it's just a random string. So my answer is Mac is not secure. Why? Because let's say you query with some M1, M2, you see the corresponding Mac output of this form, right? Then you query again with some other M1 dash M2 dash, right? And see the corresponding output. Now you can come up with, even with single query, let's say if you are querying with M1, M2 and getting the tag as fk of M1 concatenated with fk of M2, then you can generate tag for M2, M1, right? And this will be just reverse of like swapping the position of first half and second half. So fk M2 and fk M1 is a valid tag for m2 concatenate to m1. This is a new message and you have got a valid tag for it, right? So MAC is not secure. This type of questions only you will get. Also revise the concepts of CPA security and CCA security. Then there is authenticated encryption, where you have both. You need to have both CCA security and ciphertext integrity. Ciphertext integrity says that by looking at a communication, right, like the ciphertext message ciphertext pair, you should not be able to come up with a new modified ciphertext, a ciphertext that you have not seen earlier, but this ciphertext should decrypt to a valid message, right? If you are able to do that, then ciphertext integrity property is not true for that particular encryption scheme. So, and if both CCA security and ciphertext integrity is there, then you are able to achieve a authenticated encryption scheme. We also did see that for achieving authenticated encryption, encrypt then authenticate approach is a valid approach, where you use a secure symmetric key encryption scheme, right? And with that, so the symmetric key encryption scheme can be just CPA secure, and with that you apply a CMA secure message authentication scheme. You encrypt the ciphertext, you authenticate the ciphertext using the MAC algorithm and send the ciphertext and its corresponding tag as the whole ciphertext of authenticated encryption scheme, and this is indeed satisfying the authenticated encryption that we had seen the proof. So go through those concepts again. There was this concept of one-way function, one-way permutation, right? Also you did go through the DES construction, attacks on them, RSA crypto system, attacks on them, on the naive construction, Elgamal encryption scheme. Those were studied recently in the last few weeks, right? Elgamal encryption, RSA crypto system, RSA signature scheme, full domain hash. Just recapitulate each of the concepts briefly. Anything else? You had seen how PRFs can be generated from PRG, or PRG can be achieved from PRF. Fistel network you had seen, right? Pseudorandom permutation and strong pseudorandom permutation. So pseudorandom permutation is like pseudorandom function only. It's just that the input and output space are same. So every output will have a inverse. It's a bijectic mapping, 1 to 1 and on to. And also pseudorandomness property satisfied, then we call it a PRP. And a strong PRP is where the adversary has access to both forward direction, like from input space to output space, and also access to the inverse function of the PRP as well, where given y, the adversary can also query for f inverse of y. So in that case, even if with the access to PRP oracle and inverse PRP oracle, the adversary is unable to distinguish between the outputs of PRP from a truly random string, then we call it a strong PRP. There was the concept of MAC and strong MAC also. So in MAC you say that in the query phase you see some message tag pair, query with some message, see the corresponding tag, and in the final phase the adversary should come up with M star T star, where M star is a completely new message than all the message queried in the query phase. But in case of strong CMA security, we say that m star may be equal to some query phase message, but its corresponding tag should be different from the tag it had seen for the same message in the query phase. So usually CMA security corresponds to deterministic MAC, whereas SCMA security defines the security notion of a randomized MAC. You had also seen that for encryption scheme, we saw that usually a stateless encryption scheme is a stateless encryption scheme is usually needs to be randomized in order to achieve CPA security, right? So randomness is necessary during the encryption process, but decryption process is always deterministic. For MAC, it is not necessary to have a randomized MAC. You can have deterministic MAC as well. In case of CPA security, the adversary has access to encryption oracle, right? And in case of CCA security, the adversary has access to both encryption oracle and decryption oracle. So just note these key points that you will require to solve the questions in the exam. Also modes of cipher you had seen, right? ECB mode of encryption, CBC mode of encryption. Then you had this padding oracle attack, right? Where you were able to exploit the decryption error message in order to retrieve the whole message block, right? Padding oracle attack. Anything specific you have in your mind?
Ma'am, could you please show the calculation of modular inverse, like how to do it very quickly?
I don't think you will get any question of like I said that it is not really a computational number theory course or something like that. So ideally you will not get any question that are like computation heavy. Like if you have such questions, there must be some catch, right? So that you should avoid any detailed computation, right?
Okay, ma'am.
Okay.
Ma'am,
Yes.
can you please explain recap on hash and sign paradigm?
Hash and sign. Okay. So as the name suggests, first you hash any arbitrary length message, right? And then use the signature scheme, and also the hash function should be collision resistant, right? So usually your signature algorithm has a certain input space, right? Say so your, let's say, signature scheme has certain message space M and signature space S, and your signature scheme, if it is a secure signature scheme for message chosen from this domain, then it is satisfied that even after seeing mi sigma I message signature pair, you should not be able to forge a signature on an unseen message. So it's similar to this, that you should not be able to come up with a valid sigma star on a new message m star. That is the security of your signature scheme, and we call it the signature forging security game, right? With negligible probability the adversary should come up with such valid message signature pair. Now in hash and sign, you extend the possible message space to arbitrary length, and you have a collision resistant hash function. So you map any arbitrary length message to this particular domain, right? So you take any arbitrary message and map it to this domain such that you can apply the sign algorithm, because sign algorithm is secure only if the message comes from this particular message space. But in real life you can have any message, so you have to first map it in this particular message space and then you can sign. Now this hash function needs to be collision resistant, because otherwise if you know some collision, say x1 x2 for this hash function, that will mean that h of x1 is equal to h of x2. Now if you have already seen the signature corresponding to x1, let's say sigma 1, then you will also be able to compute or come up with the new message signature pair as x2 comma sigma 1. Now because h of x1 is h of x2, then they will map to the same message in this message space and their corresponding signature will be same. That's why sigma 1 will be a valid signature on h of x2 or x2. So your Sigforge game is owned by the adversary, then it will not be a secure scheme. So in order to make the arbitrary length signature secure, you have to first map it using some collision resistant hash function to a particular message space and then apply the signature algorithm. That is hash and sign. Is this clear now? Better?
Yes, ma'am.
Okay, if you do not have any specific question, then maybe we can end the session.
Excuse me, ma'am.
Yes.
Ma'am, could you please recap the salient features of elliptic key cryptography, like the important points regarding that?
I think elliptic curve cryptography was discussed in this course in the context of discrete log hard group. So as we had seen that in groups like ZP, like some prime order subgroup of ZQ, those groups are also discrete log hard groups, but the needed parameter size is very large, making them inefficient. Like the number bit length of P and Q, those primes are very large. So we shifted to elliptic curve cryptography, where basically elliptic curve has the group operation in terms of addition, and it is usually very much efficient than the groups like prime order subgroup of some ZQ with Q prime. Okay. Now there is this for the properties of the group, you have the identity element as the point at infinity, which is assumed to be the point which is present on all the y-axis. So it is at somewhere at infinity. So that's the identity element, additive identity of the elliptic curve group. And then you have certain way of computing addition given 2 points on elliptic curve. How do you add them? So basically, let's say 2 points are there, you draw a straight line through that curve and you will get a third point where it intersects the curve, and usually you take the reflection of that point with respect to x-axis as the summation of those 2 points. So if P1, P2 are points on elliptic curve, you draw a straight line that goes through P1 and P2 and intercepts the curve at point Q. You find that point Q using simple calculation, and then you take the reflection of point q with respect to x-axis and declare that point as the sum of point p1 and p2. That is how addition is performed. What is also like I think there were certain very specific conditions were discussed for which the elliptic curve should not be used as discrete log hard proof, right? What is also like questions like computing points like on elliptic curve or something like that, those will not come to exam. You may have question like how the 2 points are added, or whether discrete log holds true for elliptic curve or not, like that. Also go through these DDH and CDH assumptions, their relative hardness, which one is more harder to solve, which one is the stronger assumption. Those, and also another thing is I should mention that please be careful about the question whether it is asking to select the correct statement or incorrect statement. So that's a bit tricky. Like we often get tricked by those questions, like you marked the exactly opposite options, right? So be careful to those things. Okay.
Also, like finding out if certain point is on that curve and all these types of questions, there's a little possibility.
Sorry, can you just repeat again?
That certain point lies or not, like to calculate the slope and all, and then find out if it lies on the curve. Those types of questions are like, is it not possible that will be there?
I don't think those maths will be there. They were not there in assignments also, right? Like computing something, you will have questions which are more of understanding, right? Concepts.
Thank you.
Yeah.
Will there any question on universal function?
Universal?
Function, strongly universal.
Strong. Yes, you
SUF.
Yes, the topic is covered, so it's just you get the concepts. There can be question like whether some particular function is SUF or not. So you basically you are allowed to query only once, right? You use those in building one time Mac or something like that. Only you do one query, you get to see the response. That will not reveal anything about the secret, but you query twice, then the security is broken, right? Okay. So I guess there is no more specific question, right? Okay then. All the best for your exam. Be well prepared and perform well in the exam. It will not be very hard if you are following the tutorials, if you are following the lectures. it will be good enough. Okay.
Will there be more multiple select questions or like one single answer?
That is hard to tell na, like the ratio of questions, single option correct, multi option, and mostly all of the, like every time they form, like the way they construct the question in website, they are always like which of the statements is or are. They are always have this kind of things. They will never see which is the correct statement. They will write which is or are the correct statement. So there is a chance of 50-50.
Okay, ma'am. Thank you.
Yeah. Okay. Thank you everyone for joining. And hope you learned something from the course, right? Okay. Bye.
Thank you, ma'am.